Okay, we got a ABCD is a square and CDE is a straight line, so we've got a right angled triangle there as well. AC is 3 root 2 and angle DEA is 60. Show that the side of the square is 3. So there, what we've essentially got here is, if I call them x and x, we've got 2x squared using Pythagoras equals 3 root 2 squared. Now then, so we've got 2x squareds here equals 9 times 2, alright, so therefore x squared equals 9, so x must be 3. Okay, so that's the first bit, pretty straightforward. Now the second bit, it says show that the perimeter of the trapezium is 3 brackets 3 plus root 3. Now we know that, and I will now write these down. Where are we? We've got this is 3, 3, 3. We don't know this. I'll call that y, and we don't know this. I'll call that z. Okay. Now what? Oh, sorry. I ought to have put on that that's 3 as well. Not that it's anything to do with the perimeter, but when we do this, I'm going to have to find the y and z using it. Alright, so we need to know what tan of 60 is. So tan of 60, because we've got, and we also need to know what is it, sine of 60 is as well. Actually, sorry, cos of 60, or sine of 60, doesn't really matter. Sine 60. Okay, so I do this by remembering that we've got a right angled triangle here. I remember this triangle drawn exceptionally badly by me, that is 1, that is 2, and that is root 3. Okay, so it's the half an equilateral triangle 2 by 2, where that's 60. Okay, so, and that's 30 as well, so it's useful if you've got to find 30. So therefore, tan of 60 equals a root 3. Sine of 60 is root 3 over 2. And actually, I'll do cos of 60 just in case we need it, is a half. Okay, so that's what I'm going to be using the whole time. So y, okay, we've got, what is it? Should we do... We'll do tan. So we've got tan of 60. Tan of 60 equals 3 over y. And we know that tan of 60 is root 3, so therefore when I rearrange that, and I'm trying to save a little bit of space here, is 3 over root 3. If you want to rationalise the denominator, it's going to be 3 root 3 over, or it's going to be, sorry, root 3, I should say. Okay. Now then, for z, okay, I've got, what is it, sine of 60 equals 3 over z. Okay, I know that sine of 60 is root 3 over 2. Okay, so therefore I've got sine of, where are we? So I've got z, z equals, where are we? 2 root 3. Okay, so there we go. So that equals 2 root 3. And that equals, what was it? It was root 3. And so therefore I can add it all up. I've got 3, add 3, add 3, add root 3, add 2 root 3, alright, which is 9 plus 3 root 3, and then you factorise it, you get that. Okay, so knowing these is absolutely crucial, okay, to this. So that's one there's one triangle here to remember, alright, which is half an equilateral triangle. The other one is where it's 45, okay, where that's 1, 1 and root 2. Okay, again using Pythagoras, and you can get what tan of 45 is. Tan of 45 is 1, cos of 45 is 1 over root 2, and sine of a sine of 45 is also 1 over root 2. But they are worth remembering. You need them for ordinary GCSE as well.